Hello, my name is Markus Armbruster, and my topic today is QEMU interface introspection from hacks to solutions. So what's this about? Why is it interesting? QEMU provides interfaces, the QMP monitor and the command line, to other programs, notably to management applications such as libvirt. QEMU evolves rapidly, so we got many interface versions. Let's have a look at the command line. Right now, we have 139 total options. If I deduct the deprecated ones and the internal use ones, I'm still left with 123 supported options. Is that a big number or a small number? Well, if I had a coin for each of them, I'd be carrying more than half a kilo of metal and wear baggy pants. It's big. This is the output of dash help, and an artist's impression of a first-time user's reaction to it. Really big. It's a section of the manual dealing with the command line. Makes for good bedtime reading. And this is how it's used in the real world outside. QMP is even bigger. It's 126 commands, 33 rents, more than 700 named arguments and results in them, and it's defined in the book-sized QAPI schema. So the QAPI schema defines a bunch of other things too, and if I omit them all, just keep the QMP stuff, I end up with about 22,000 words. Again, is it a big number or a small number? Well, this book is about the same size as the Gospel of Luke. It's a bit smaller than the book of Genesis. It's a good deal larger than the source code of our complete user manual. Let's see how the command line has evolved over the past 2 years. The red line with the round marks, that's the number of pages in the manual. The black line with the square marks, that's the number of lines in dash help. As you can see, the latter has been growing by about 20% year over year. The manual has been growing a bit more slowly, but that's probably not a good sign. QMP evolves even faster. Here the red line is the number of commands and events, and the black line is the number of words in the schema. And it's been growing by 25% year over year. So, why interface introspection? QEMU provides big, rapidly evolving interfaces. A program interfacing to QEMU can deal with that by tying to a specific build of QEMU. This is wrong talk, you can break for lunch now. Or it can figure out what the QEMU it got can do. This is easiest when the interfaces support introspection. So you can just ask. Means to inquire what they can do. Trouble is, our interfaces don't fully support it yet. In the next part, we'll explore what they do support, what has been done so far to crack this problem. This will be a journey from impractical ideas through hacks to working solutions that aren't quite good enough. Let's start with an idea, the obvious one. Check the version number. I got a QEMU here. It says it's 0.012.1, but it's a RHEL 6 QEMU. And it has changed a little bit since we forked it off upstream. The graph shows how it has changed. The black line with the square marks, that's the number of lines in dash help, and it has grown by 35%. The red line with the round marks, that's the number of QMP commands and events, and it has grown by 250%. Backports make the upstream version meaningless. In the lighter shade, I graphed the same things for upstream. And there you can see upstream has been growing even faster. And I think that shows that we RHEL developers aren't entirely crazy. Oops. So why not check the downstream version then? After all, we provide means for downstreams to add their version. Well, downstreams don't always step it for each and every build. So the downstream version is in practice often meaningless too. And even if it wasn't, the number of downstreams times the number of releases results in a huge number of versions, and keeping track of what each and every one of them can do, that's a nightmare. So you may say, what do I care? That's a downstream problem. Let downstreams worry about it. Let me rephrase it as an upstream problem for you. Have a look at the 2-4 development cycle. In about 4 months, we touched over 70,000 lines in 2,147 commits. For 1,901 out of these, the version was 2.3.50. If you're developing software interfacing with QEMU, you don't want to wait for a month for the version number to change before you start interfacing with new stuff. So version numbers are of no use, of no practical use to deal with this problem. Here's another idea. Just try to use it. If it's not supported, it'll fail. This one actually works fine in simple cases. For example, libvirt first tries QMP command inject NMI, and if it fails, it falls back to the older HMP command NMI. In not so simple cases, however, it can be complex, slow, and fragile. You may have to look at the error to figure out whether the thing failed because of something in there you try to do is unsupported, or whether it failed for some other reason. And that's always a pain. You may want to figure out whether this thing is supported before you actually try it in anger. So you want to run a probe. And that probe may need complex scaffolding. It must also avoid unwanted side effects, and that adds to the complexity. But this is all theory, so let's look at a practical real-world failure of just try. We added command block commit in 1.3, and it works roughly like this. You run block commit, it starts a block job and succeeds. The block job runs for a while, and when it's done, it sends event block job completed. libvirt just try to use it. Run block commit. If it succeeds, wait for the event. Worked fine. Until 2.0. Before 2.0, block commit fails for the active layer. But then we implemented that. It succeeds. But the block job it starts doesn't complete all by itself. You need to initiate completion with an explicit block job complete command. Old libvirt has no idea and hangs waiting for the event that never comes. The lesson to take away from this example is that relying on behavior in error cases is inherently fragile. And that's what you do when you just try. Time to get desperate. QEMU already tells us what it can do, sort of, in help texts. Many ways to get help, dash device help, and so forth and so forth. But this has serious drawbacks. Passing help is painful and fragile, but more seriously, the help text becomes de facto ABI. We've been in situations where we couldn't improve help for our human users for fear of breaking tools. Finally, help is perpetually incomplete. For instance, there is -drive format equals help, but there is no -drive IF equals help. Nevertheless, everybody did this until QEMU grew real interfaces. Here's the first one of those interfaces. It's QMP command query commands. Looks like this. You run query commands. You get back what is effectively an array of command names. This is actually QMP introspection, just a very limited form of it. You can use it to check for presence of commands, but it's entirely silent on arguments and results. It's very useful, but we really need arguments and results now. For the command line, we got something similar, if more ambitious. You run the command query command line options. You get back an array of objects, and each object describes an option, gives the option name, and an array of option parameters, names, and types. This tries to be command line introspection. Why try? What's wrong with it? Oh, dear God, where to begin? This chart shows status of query command line options for all the supported options. The dark green pie is where the information it returns is correct and complete. The yellowish green pie, well, it's correct and complete, except the option name is pointlessly wrong. So you need to know how to map the incorrect option names to the correct ones. But that's just a minor annoyance, so it's still green for me. The small yellow slice, you might not be able to see it. That's when it tells you about some parameters, but forgets about others. The orange slice, that's when it forgets about all of the parameters. And the red slices is when it has no information at all. So for some of those red options, I can engage in a bit of hand waving and say, okay, this option is inessential. Say it's a convenience option for human users, and tools want to use a more powerful long form anyway. And I painted that dark red. But the biggest slice by far, that's missing no excuse, bright red. Now, this is probably better, still better than nothing, but it's certainly less than needed. Moreover, it's insufficiently expressive. There are legitimate introspection questions we just can't answer. For instance, what formats are supported by -drive? It can only tell us that parameter format, is a string. Well, we already knew. What parameters are supported by -cardiff socket? It can only tell us the parameters supported by some backend. It can't tell us the parameters supported by this particular backend socket. These are structural weaknesses, so the command is in worse shape than merely incomplete. Here's a technique I like to call look for a witness, and it's best explained by example. In 0.14, we added an option -spice, and libvirt needs to probe for it. And there was no query command line options back then, rendering the question whether it tells us anything about -spice mood. So what to do? We didn't want to scan -help. However, together with -spice, we added QMP command query spice. And we can probe that with query commands. So we use query spice as a witness for -spice. We look for query spice, and if it's there, we just assume that -spice is also there. This is useful when a direct probe is impractical and a suitable witness exists. So what if all of these techniques fail and we still need to know something? What can we do? Well, there's one thing we can always do. We add a special ad hoc query command that returns whatever we are interested in. And we've done that a couple of times. There's query CPU definitions, query machines, query TPM types, query this, query that. The question is, how many more of these ad hoc queries do we want? Maybe it's time to add a more powerful query instead. So, where do we stand now on this problem? current introspection solutions work, but they won't cut it for much longer. Query command line options is too incomplete and inexpressive. Query commands is too limited. We need arguments and results. And adding a query foo for every foo will result in a mess. It's time to crack QMP introspection for real. And that's what I'll show you next. Here's the basic idea. Interface introspection turns the interface into data the client can retrieve and analyze. The QMP is defined by the QAPI schema. The schema is data. So why not let clients query for it? This looks like a good idea, but actually isn't, because the schema is geared toward humans, not machines. And more seriously, it mixes up ABI aspects with internal detail. So a refinement of the idea is, instead of simply dumping the QAPI schema, you expose only its QMP via ABI aspects in a format that's easily consumed by machines. And that's what I got cooking in my tree. There's a command, query schema. Looks like this. You run it, you get back an array of objects. And those objects expose the QMP via ABI as defined in the schema, commands and events with arguments and results. Arguments and results are fully typed. We have a reasonably expressive type system. They're enumerations, so you can find out acceptable values. They're compound types, and so forth, and so forth. And this work has been done by myself with heaps of help from Eric Blake. Just the other day, he observed that I nerd-sniped him. So let's try it. Let's introspect the command, the simple one. I pick query block. It takes no argument, returns an array of block info, whatever that is. On the top, you see the QAPI schema for the command. And on the bottom, you see what query schema returns for it. And now let me show you how to read this. Query block is a command. It has an empty argument type. That's a bit weird, but in the schema, there are 3 ways to say a command has no arguments. You omit the arguments key, or you say arguments, open curly, nothing, close curly. Or you say arguments is this type over there, and that type is empty. So I normalize to empty object for simplicity. And finally, its return type is an array of block info. Except the type name block info is masked because it's not ABI. Overall, this is tediously explicit on purpose because that's how machines like the input. Easy, isn't it? So let's do something more fun and interesting instead. Let's introspect introspection. So here's the top again, schema for the command, query schema instead of query block, and on the bottom what query schema returns for it. And it's really the same, except it's schema info instead of block info. So the new part, the part we want to look into now, that's schema info. Let's explore it. This is how schema info is defined in the QAPI schema. And I'm afraid this is all gobbledygook to normal people. So let me decode it for you. Schema info is a variant record. It has common members, name, and meta type. It has variant members, and the variant members depend on the value of meta type. If meta type is command, there are members archetype and red type. For array, there's element type. For object, members, tag variants, and so forth, and so forth. Let's introspect schema info. Read it real slow. It's an object type. It has a name and a meta type. It has variants, and meta type is the type tag for them. It has a bunch of variant cases, and each case applies to a value of the text type. And the variant members for each case are given by yet another object type. I glossed over the types of name and meta type, so let's have a closer look. Names type is str. It's a built-in type, and on the wire it's JSON string. Meta types type is an enumeration with these members, and they shouldn't surprise anyone by now. Finally, let's have a closer look at one variant. I picked enum. So the variant cases type is an object type. As I said, it would be. The object type has just one member called values, and its type is array of string. Taken together, when the meta type is enum, there is one additional member called values, and its type is array of string. Time for a quick peek under the hood. The QAPI schema is compile time static, so we can generate schema info from it. That's what we do. The generator is a small Python program. It's just 160 lines of code. The necessary refactorings to make it possible, that was a bigger job. The complete info, what query schema returns, that's a bit over 70 kilobytes right now. So we should probably support caching it by putting a hash or something in the QMP greeting. The whole thing is still a work in progress. Check it out in my Git repo. As always, the reward for useful work is more work. And here's some of it. QMP introspection has limitations. It can only see QAPified commands. And there's one left that still isn't QAPified. That's device set, so you can't see that. Likewise, it can only see QAPified arguments and results. And there's one command where we cheat. That's netf add. So you can't see most of netf add's arguments. In general, it can only be as good as the QAPification. For instance, QMP command add client takes arguments protocol and TLS. TLS is an optional Boolean. It is accepted only when the protocol supports it. Unfortunately, the QAPI schema isn't written in a way to express that. So you can't see in introspection whether the protocol supports TLS. Sure would be useful. How could we clean up the QAPification of netf add? The problem is, well, it has common arguments, and among them the argument type, and then it has type-specific arguments, and the type-specific arguments are all missing. We need to QAPify them without upsetting the QMP wire format. Turns out this wire format matches QAPI QMP's flat union type, and that leads to a possible solution. If we support unions as command arguments, then all we need to do is code up the matching flat union type, done.
Actually, there is a problem that netdev is not type safe. You can pass a TCP port as a string and it will accept it, so it doesn't match the union type.
That's a horrible misfeature, and we have to hack around it, so it's not quite that easy. So I lied to you. How could we QAPify device add? Now, on the surface, it's just like netf add. It has a bunch of a few common arguments, one of them driver, and then it has driver-specific arguments. Unlike netf add, the drivers are collected and their arguments are collected only at runtime. But the QAPI schema is fixed at compile time. Choices. We could collect drivers at compile time, but that would be work. We could make the QAPI schema dynamic. Interesting, but even more work. We could forgo driver-specific arguments in the schema, or that defeats introspection. We haven't decided what to do yet. There's work to do on QAPI itself. On the way to introspection, we got ourselves real test coverage. We completely replaced our internal representation of the schema. We fixed many bugs and marked more as fix me, and we plugged many documentation holes. Work left to do includes fix the fix me's, of course. We need to finish the transition to the new internal representation. And there are opportunities to clean up the schema language and the code generated for it, and I'd like to explore them. And I think we should review the schema for imprecise quapifications such as add clients. So with QMP wrapped, what about the command line? The same basic idea applies. Turn the interface into data. The good news is our command line definition is data. We define it in data. The bad news, it's not QAPI. It's something else which is less expressive and leaves more to code. We are left with choices. We can build non-QAPI command line introspection, but it can only be as good as the data, which means not very. Or we can rebase the command line onto QAPI. And that's another big chunk of work. We could try to rely on QMP introspection to provide us a witness. But that assumes that we can always find a suitable witness. No conclusion yet. And with that, I'd like to conclude my talk, say thank you, and open it up for questions.
So it's not a question that probably can have an immediate answer, but what about the QOM schema? So querying properties, do you have any ideas or any plans or something? It's just yes or no
sort
question.
Of like device that, just harder.
Hi. Have you thought about some kind of versioning? I'm thinking about the case where we extend the functionality of an existing command, but we don't really change the API. How do we know if the command supports the new functionality or not?
Don't. Change the API.
But there's cases where we are not changing it.
We shouldn't.
Well, the example that you gave is a
block commit, yes. That was badly done. The change should be visible in the ABI, really.
Well, I'm actually working in extending the block stream command, and initially my plan was to actually change the API. But then I was suggested not to change it, but to reuse to extend the existing API, keeping the same arguments.
You need to change something, or QMP introspection will be of no use to you. And that might be just fine. Depends on the case.
I think this particular case is not really a problem because there's other ways to figure out that functionality. But I was thinking more about the general case.
You had a few not decided yet there, and
yes.
I would strongly argue for the move to QAPI and the move to make QAPI dynamic enough to handle the device cases. That would make everything more easy.
The job security.
In the long run, it's small steps towards
yes,
that goal.
It's a good solution.
Yeah.
Anything else? Then we are done. Thank you.